Instruments used for this experiment are Fisher Scientific Nicolet IS-10 IR spectrophotometer. It is going to be shown in Demo B on how to use the instrument. And then a 45 MHz picoSpin NMR spectrometer will be shown in Demo C on how to operate the instrument. Both are demonstration videos. Analysis of second unknown. This unknown is a small organic molecule and it's a liquid. Molecular weight is less than 200. Maximum number of carbons, 13. From the IR spectrum, determine the functional group. This unknown is either an alcohol, a ketone, or an ester. In the IR spectrum, the OH stretch is about 3600 per centimeter and it's a strong, broad absorption band. For both ketone and ester, you will see the C double bond O stretch. It's about 1700 per centimeter and it's a strong absorption band. From the NMR spectrum run in a 45 MHz instrument, you can determine the R groups. First, for the alcohol, this H on the OH, it's about 5 ppm. The H's on the R, or aliphatic chain, it's spread out from 1 to 4 ppm. The closer it is to the alcohol, or the oxygen, the more shifted it is to the left, or higher ppm, or more shifted downfield. For the ketone, the H next to C double bond O, it's about 2 ppm. For an ester, the H and the R on the left side of the structure, it's about 2 ppm, while the H next to the oxygen, it's about 4 ppm. From this information, you can determine the number of H's in the NMR spectrum and then in the structure. You can determine the length of the carbon chain, and then finally you can draw the structure of the molecule based on the NMR and IR. Assign IR absorption bands and NMR peaks based on the structure. Search IR and NMR data online related to the proposed structure. Take note that NMR data online typically will be run on a 300 MHz instrument and the peaks are much more resolved. Our NMR spectrum, some of the peaks are broader because it's run in a low field NMR instrument, but you can still see the cluster of peaks. So take note that when you're searching online, those NMR data are typically run in a 300 or 400 MHz instrument, and they're much more resolved, and then the peaks are split. Finally, write the final lab report.